Okay, we are asked to find the molar solubility of silver chloride, which has a really small KSP, in 0.5 molar ammonia, which will react with silver ions and has a very large equilibrium constant. So, the idea here is that even though silver chloride is insoluble, has a very low solubility because of this tiny KSP, if we introduce into the system some ammonia, we can make it more soluble because the formation of the complex ion is very product favored. It has a large formation constant. So let's figure out what that overall new equilibrium constant is going to be first of all. So we can do that by combining the two reactions that occur. So if the silver chloride is going to dissolve, it's going to form silver ions and a chloride ion. Okay? Well, that's one reaction that can occur. That is the reaction designated with the KSP. But the other reaction that can occur is the silver ion can find two ammonia molecules to form a silver ammonia complex ion. And that has a formation constant associated with it. Well, let's just add both of those reactions together, and what you'll see is that we have a silver ion on each side, so they cancel out. And so when I sum these two reactions together, I get silver chloride, AgCl, solid, plus 2 ammonia, aqueous, react in a reversible way to form silver ammonia complex ion, aqueous, plus the chloride ion, aqueous. Okay? So we effectively get the silver chloride dissolved by having it undergo the reaction with the ammonia. Now, we talked about this back in chapter 14. I can determine the equilibrium constant for this reaction, okay, by manipulating the equilibrium constants of those two reactions. Since I added these two reactions together, remember that what I do is I multiply those two equilibrium constants together. So this equilibrium constant of this reaction is going to be equal to the KSP times that formation constant. And so the KSP is 1.8 times 10 to the minus 10, and then the formation constant is 1 times 10 to the 7. So overall, that equilibrium constant is going to be 1.8 times 10 to the minus 3, okay, which is much larger than just the KSP of the silver chloride. Now, what we're going to do, we haven't really answered the question yet, we just have a piece of information that's necessary for answering the question. To answer the question, we need to set up a table using this reaction. So that's going to be the reaction in our rice table. So the reaction is the silver chloride will find two ammonia molecules and react with them in a reversible way to give us the, that's a plus 1 ion, sorry, to the silver ammonia complex ion and the chloride ion. Okay, so those become the parts of our equilibrium table. We get our rows, we get our columns. We leave out the solid. Okay, and here's where we start filling in the blocks. So we are told that the concentration of ammonia is 0.5 molar. So that is going to be the number that I put right there. Okay? And I initially have 0 amount of that, 0 amount of that. So it's going to shift to the right. So we're going to lose, in parentheses, because it doesn't really become part of the calculation, but we're going to lose X amount of the silver chloride. Oops, that should not be a positive ion. Sorry about that. This is the positive ion. And then we're going to lose 2X amount of that, because for every one of these that I lose, I have to lose 2 of these. And so then we're going to gain X amount of that. We're going to gain X amount of that. And so we bring our columns down just like every other rice table that we've ever done. Okay, and now we can substitute that into an expression for this equilibrium constant that I just determined. So what would that be? That would be the products over reactants, where coefficients become exponents, and we leave out solids and pure liquids. So in the numerator, I'm going to have the concentration of this complex ion, the silver, the silver ammonia complex ion, times the concentration of the chloride ion over the concentration of ammonia squared. And I leave out the AgCl because it is a solid. Okay, so then I can just plug in the terms that I have from my rice table into this equation. So that's going to be x squared over 0.500 minus 2x, all that squared. And that's equal to this number that I calculated up here, the equilibrium constant for this reaction, which is 1.8 times 10 to the minus 3. Okay, so then you just tell your calculator to solve for x, and if you do, you get that x is equal to 0.0196. Okay, now that is going to be the solubility. That answers the question because If you go back up to what the question says, it says, what is the molar solubility of silver chloride? Well, look down at our rice table. X is the amount of silver chloride that goes into solution. That's what that minus X represents. So if I solve for X, then I've also determined the molar solubility. So I've answered the question.